Hello and welcome to some video instructions on how to do your linear regression assignment. So start by signing into your D2L course and then click assignments. Once there, you'll see a little link for linear regression. You can read the instructions as to exactly how to submit it there. But let me go over some of the points that would be hard to discuss in written form and show them to you in visual form. So the first thing you want to do is you want to find yourself a set of data that you're going to use. So for myself, I typed in number of opioid overdoses by year, and the second data set there looked pretty good. So I chose to use this one. Now we're going to do our analysis in something called Desmos. So you're going to want to go to desmos.com. Now, if you've not been there before, if you don't have an account, when you click to log in, I would suggest you create an account, use your student email, and give yourself a nice memorable password that's not easy to hack. But sign in with your email. And the advantage of that is that you can save your work, go back to it later, share links with people, myself included. So it really has some nice advantages to signing in. Once you've got signed in, then we're going to start creating our Desmos Desmos page here. You might want to start by copying the link from where you got your data, and then click this little plus icon in the upper left-hand corner, go down to Note, and then you can paste in Note, and then maybe, let's say, I don't know, looking back at this, the first actual number I see here looks like for the year 2015. So the year 2015 is going to be my year zero in this analysis. So let me go back over to my Desmos page, type in x equals 0 is the year 2015, and so on. You might also want to type some other notes like, I don't know, your name, Jeff Parents, and then it's time to begin the analysis. So to do that, we're going to need to enter the data. So you click table. If you actually have the data already saved in, say, an Excel spreadsheet or something similar, you should be able to paste it and it'll create the table for you. But for right now, let's type in the number 0 for year 2015. And in that year, there was 52,404 opioid overdoses. Now, I'm not going to make you look at me type in all this data, so let's just kind of zoom ahead a little bit. And let me get rid of some of these. Here's my full data set. Now, when you type in this full data set, chances are you might not see any of your numbers on the screen. It might look like this. That's because although you can see the numbers 0 through 6 on the x-axis, you're going to need to see a little bit higher on the y-axis. Right next to your table, there's a little zoom fit icon here in the form of a magnifying glass. So if you click that, it should zoom things in so you can see your actual data. There it is. Now, as far as finding the equation for that data, well, that's where we're going to let Desmos do its magic. So type in the letter Y and then followed immediately by the number 1. Now it's going to take and place that number 1 as a subscript. That's exactly what you want to happen. Then if you hit the Shift key and a tilde, for those of you who are taking a Spanish class, it should be in the upper left-hand corner of your keyboard. We want to fit what's called a linear regression or a linear model. Now those models are the form of mx plus b. I'm going to write it as ax1. I'll just type in the number 1. It'll automatically put it down there as a subscript. And then we want to type in plus b. That's our linear model. And that's not a bad fit. I mean, is it perfect? No. But is it decent? Yeah. And you can tell it's decent by this statistic here. This r squared is going to be a number between 0 and 1. If all these points lie directly on a straight line, then r squared is going to be 1. If things are more chaotic, r squared could be as little as 0. So For this assignment, you probably want R squared to be at least 0.7 or higher. Now, once you've got a decent set of data and R squared is at least 0.7, then we can look at what that data is saying. So it tells you the parameters, tells you the value of A1, that's your slope, is 8,480.19. We'll just round it off to the nearest integer. The y-intercept is about 48,582. So let's kind of retype that model. We're going to type it in using, instead of a y, we'll use f of x equals 8,480x plus 48,582. And that looks a little bit better. We can shut this graph off. And we can get a little bit fancy if we want to. You can type in a curly brace, then x greater than, and just type the equals to key, and it'll put that equals right underneath. X greater than equal to 0, closing brace like that. And wow, there's your model. Pretty good. You can make this screen a little bit easier to read if you click the tool icon in the upper right-hand corner and then press the capital A. That gives us a nice graph here. We can also, based on the way we've done this, use that to make predictions. Say, for instance, you wanted to know, well, what would that predict about the year 2023? Well, the year 2023 is 8 years past the year 2015. So that would be f of 8. F of 8 is 116,422. If you wanted to actually put that point on the line, you can. You can type in 8, comma, f of 8. Or if you wanted to, you could also type in 8, comma, 116,422. Same difference. So now the last and most important part about this is to interpret the slope in words. So in this case, x is the number of years, f of x or y is number of overdoses. And what the slope is saying is that each year, the number of opioid overdoses is increasing by about 8,480. Wow, that's staggering and that's sad. But that's the interpretation that I want. Let me give you another example of that kind of interpretation. This one is done for the number of miles that I've put on my car. So X in this case is the number of days that I own my car. And then Y is the number of miles that I had on that car. So here's the regression. And let's do the same thing as we did last time. Get rid of all the stuff to the left of the y-axis. And we can make that a little bit darker as well. So the regression equation is this one. Y equals 19.2x plus 676. Now, x here is the number of days that I've owned the car. So the slope then is going to help me understand how the mileage of my car has increased as a function of time. And from what the slope is telling me, every day that I own this car, the number of miles on that car increases by an average of about 19.2 miles per day. So that's the kind of interpretation that I want you to give me for the slope. It's in words. It has nothing to do with the fact that slope is rise over run, at least in terms of the words that I want you to give me. If you have any questions about that, please let me know. Otherwise, good luck and enjoy the assignment.